integration of trigonometric functions. So we've already had a look at deriving trig functions, and for integration we're just going to go in reverse. So if we have the integral of cos x dx, that's going to give us sin x plus a constant. If we have the integral of sin x dx, this is going to give us minus cos x plus a constant. And if we have the integral of sec squared x dx, this is going to give us tan x plus a constant. But we're not going to always have just the integral of simple trig functions, so let's look at some more general cases. So if we have the integral of cos ax dx, this will actually give us 1 on a sine of ax plus a constant. If we have the integral of sine of ax dx, this will give us minus 1 on a cos of ax plus a constant. If we have the integral of sec squared of ax dx, this will give us 1 on a tan of ax plus a constant. So let's have a look at some examples using those. So let's have a look at the integral of cos of 2x dx. So applying what we just learnt, this would give us 1 on 2, where our a is 2, sine of 2x plus a constant. Let's look at the integral of minus sine of minus 3x dx. So here we can pull the negative out of the integral. So we have minus outside of sine of minus 3x dx. And applying the rule we just learned, we got the minus out the front, and the integral of sine is minus cos. And then we also have to multiply by 1 on a. In this case, our a is minus 3. So we're going to get 1, so minus 1 on minus 3, cos of minus 3x plus a constant. The 3 minuses will turn into 1 minus. So we get minus 1 on 3 cos of minus 3x plus our constant. Let's have a look at the integral of sec squared of a half x dx. So here we're going to get 1 on a, and our a is a half, so we're going to get 1 on a half, tan of ax, so tan of a half x plus a constant, and 1 on a half just gives us 2, so we get 2 tan of a half x plus a constant. So we're going to have a look at some more general cases as well, using the reverse chain rule. So if we have the integral of the f dash of the cos of the f of x dx, this is actually going to give us the sine of f of x plus a constant. If we have the integral of f dash of x of sine of f of x dx. This is going to give us the minus cos of the f of x plus a constant. And if we have the integral of f dash of x of sec squared of f of x dx, this is going to give us the tan of f of x plus a constant. So let's have a look at some more examples. I'm going to have a look at the integral of 2x cos of x squared dx. So if it's in reverse chain rule form, we need the derivative of our function to be multiplied by the trig function, and the derivative of x squared is 2x, so it is in that form. So we know the result is going to be in the form of sine of f of x. So we get the sine of f of x, and our f of x is x squared plus a constant. Let's have a look at the integral of 4x plus 4, all multiplied by the sine of x squared plus 2x dx. So in this case, our function is x squared plus 2x, and the derivative of that is 2x plus 2, and that's what we need outside of our trig function. But we have 4x plus 4, but if we just factor out a 2, and we'll take it outside the integral, this will leave us with 2x plus 2, exactly what we need as our derivative. So we get that multiplied by the sine of x squared plus 2x dx. And now the derivative of our function is being multiplied by our trig function. So we can rewrite this as we've got our 2 outside the integral as well. And the integral of sine is minus cos, so we need a minus. And we get the cos of the function, which is x squared plus 2x and plus our constant. Let's have a look at one more example. Let's have the integral of x squared sec squared of x cubed dx. So here our function is x cubed, and the derivative of x cubed is 3x squared. So that's what we need to be multiplied by our trig function, but we just have x squared. So we're just going to manipulate this slightly and put a 3 in front of the x squared, because that's what we need, but we can't just change the question. So we'll multiply everything by a third. So the third and the 3 will simplify to 1, so we haven't changed the question. And we get sec squared of x cubed dx. And now we have the derivative of our function multiplied by our trig function. So now we've got the third outside the front, and we know that the integral of this is going to be tan of our function, which is x cubed, and we add our constant.